Welcome! Today, we're diving into a brand new explainer, and we are embarking on the absolute ultimate cosmic journey. We're going to take a complete tour, starting from the familiar ground right beneath our feet, all the way out to the very edge of the universe. Time, space, matter, it all exists within this incredible, sprawling structure we call home. So definitely fasten your seatbelts for this one because this trip is going to be incredibly exciting, completely mind-bending, and full of some seriously vast unknowns. If you just drop whatever you're doing for a second and imagine looking up at the night sky, what do you actually see? It's this beautiful, massive black blanket, right? Just completely sprinkled with twinkling stars. It's stunning. But here's the crazy part. Every single star we can see with our naked eye is just a tiny localized patch within our own Milky Way galaxy. We are basically a tiny drop in a massive cosmic ocean of galaxies. So does our little galaxy even matter in the grand scale of the cosmos? Let's lift off and find out. Section 1. Leaving Earth's familiar neighborhood, from the ISS to the moon. Okay, let's dive right into this. As we blast off from the Earth's surface, our world quickly shrinks into this gorgeous blue sphere. And almost immediately, we run into the incredible footprint of human engineering right in our own backyard. 27,588. That is the staggering speed, in kilometers per hour, of the International Space Station. It's the largest object humans have ever built in space. It orbits roughly 400 kilometers above us, and it's moving so fast that it circles the entire globe 16 times in just 24 hours. No way, right? And as we push slightly higher than that, we hit this massive web of thousands of satellites just blanketing our orbit, acting as humanity's eyes and ears. Pushing about 400,000 kilometers outward, we finally reach the moon. Now, its surface is basically a scarred battlefield, and that's because it has absolutely no atmosphere to burn up incoming meteors. But that lack of atmosphere also means something really cool. The footprints left by astronauts like Neil Armstrong, they're going to remain completely undisturbed for centuries. Now, contrast that silent, lifeless rock with the sun, which is sitting 150 million kilometers away. It is a blazing powerhouse. It's so massive that millions of Earths could fit inside it. And its gravity is literally the anchor that controls our whole solar system. Now, look at this comparison. Venus is often called Earth's sister planet due to its similar size. Actually, scratch that. It's more like an evil twin. The reality of Venus is an absolute hellscape. It suffers from this runaway greenhouse effect, where the sun's heat gets completely trapped. Instead of water, it rains sulfuric acid. Yeah, you heard that right. And the surface temperature sits at a blistering 465 degrees Celsius. Absolutely nothing can survive there.
Moving even closer to the sun, we smack into Mercury. Visually, it kind of looks a lot like our moon, just completely covered in craters. But the temperature swings here are beyond extreme. Its proximity to the sun creates this totally unforgiving environment, where daytime temps can soar past 400 degrees Celsius. But because it lacks an atmosphere to hold on to any of that heat, the nights plunge straight down to negative 170 degrees Celsius. Talk about whiplash.
So, let's swing outward to Mars, the red planet. Scientists are completely obsessed with Mars because, in a way, it's essentially our past. It once had oceans, flowing rivers, and a thick atmosphere. Today, sure, it's a barren desert, but it holds monumental features. I mean, it's home to Olympus Mons, an ancient volcano 3 times taller than Mount Everest. That makes it the highest peak in the entire solar system. We're actively searching for fossilized microscopic bacteria in the soil there, and honestly, it remains our very best bet for future human colonies. Section 2. The giant outer planets and beyond the asteroid belt. Honestly, the inner solar system was just a warm-up. As we push further out, things are about to get significantly larger, much colder, and a whole lot stranger. We are now entering the asteroid belt. It's this massive ring of cosmic debris just floating between Mars and Jupiter. And what's really fascinating here is that 4.5 billion years ago, all this material was supposed to form another massive planet, but it never did. Why? Because an immense cosmic bully just kept pulling it apart. And that bully was Jupiter. Jupiter is so unimaginably huge that if you combined all the other planets together, they still wouldn't equal its size. And this number 3, that is exactly how many entire Earths you could fit just inside Jupiter's great red spot. To put that in perspective, that spot is actually a violent ancient storm raging on a planet made entirely of gas. If you tried to land on Jupiter, you wouldn't even find a solid surface. You just sink into the crushing atmosphere. Now, what's really interesting about this slide is that while these gas giants are incredibly hostile to life, their moons might not be. Take Europa circling Jupiter. Scientists strongly believe there's a literal liquid water ocean sloshing around beneath its frozen ice crust. And then there's Titan orbiting Saturn. Titan actually has a thick atmosphere, complex weather, and flowing rivers. But they aren't water, they're rivers of liquid methane and natural gas. Scientists theorize that billions of years from now, when our sun expands into a red giant, Titan might just warm up enough to become a habitable, Earth-like home. How cool is that? Section 3. Crossing the solar system's edge into the Kuiper belts and beyond. Flying past Saturn with its dazzlingly beautiful rings and waving goodbye to the telescopically discovered ice giants Uranus and Neptune, the sunlight starts to grow remarkably faint. We are crossing the boundaries of the known solar system here. Welcome to the deep freeze of space. We've arrived at the Kuiper belt, a region 20 times wider than the asteroid belt. This is where Pluto lives, alongside these massive icy objects that are actually large enough to have their own moons. Further out is Sedna, a dwarf planet discovered back in 2003. Sedna is a staggering 13 billion kilometers away from Earth. It takes 10,000 years just to complete a single orbit around the sun. The true scale of just our own backyard is totally mind-bending. But humanity has actually reached even further, 19 billion kilometers. Let that sink in. That is how far the Voyager 1 spacecraft is currently sitting from Earth. It is out there traveling 20 times faster than a speeding bullet, making it the furthest human-made object in existence, slowly peeling back the mysteries of interstellar space. So the crucial point is, where does our solar system actually end? That boundary is the Oort cloud, which is this gigantic, spherical shell of icy comets. Scientists believe comets from right here delivered the primary water to Earth's oceans and quite possibly even the microscopic bacteria that kickstarted life. Beyond the Oort cloud, the sun's gravity finally fades. Space becomes so profoundly pitch black that you would literally need infrared vision just to see anything at all. Section 4, Journey to the Nearest Stars, Entering Pitch Black Space. You know, we've traveled billions of kilometers, yet on a cosmic scale, we have barely taken a single footstep out our front door. It is time to leave our sun behind and head into the vast sea of billions of neighboring stars. As we look for new worlds out there, our primary target is always the habitable zone. It's basically the Goldilocks spot, that precise orbital distance where a planet can maintain liquid water, which is the fundamental prerequisite for life as we know it. And the discoveries we're making here are just thrilling. Just 4.3 light-years away is the Alpha Centauri system, which hosts a planet called Proxima Centauri b, sitting right in the habitable zone. But even more exciting is Gliese 581, about 20 light-years away. Orbiting this star is a planet that is practically an exact match to Earth. The potential for an advanced alien civilization existing right there, it's incredibly high. Section 5, Galaxies and Vast Superclusters. Leaving the Milky Way. There are billions of stars just in our galaxy alone. Counting them all in a human lifetime is literally impossible. So let's pull back. Let's leave the Milky Way entirely and check out the true architecture of the universe. Just to help wrap your head around our galaxy's size, look at this number, 105,000 years. That is how long it would take light itself, the absolute fastest thing in the universe, just to travel from one side of the Milky Way to the other. Our galaxy contains roughly 200 billion stars. Yet, as massively huge as that sounds, it's practically nothing in the grander universe. Let's step through this cosmic zoom out, because this is where it really gets crazy. Our massive Milky Way? It's just a single member of a galactic neighborhood called the Local Group, spanning 10 million light-years. But zoom out again, and our Local Group is just a tiny patch within the Virgo supercluster, which is 110 million light-years wide. Zoom out one more time, and that entire Virgo supercluster is swallowed up by the Laniakea supercluster, stretching an incomprehensible 520 million light-years across. At this scale, our entire galaxy isn't even a visible dot. It's just gone. Section 6, the observable universe's edge and the limits of our knowledge. I mean, my mind is completely spinning just thinking about that scale. But incredibly, that massive Laniakea supercluster is just a tiny speck itself when we zoom out to the ultimate limit of what we can see. Because here's the kicker. Everything we have talked about in this explainer today, every planet, every star, and all those millions of superclusters,
It all makes up only the observable universe. It's just the known universe, the specific bubble of space where light has actually had enough time to reach our telescopes since the dawn of time. But the universe doesn't just stop there. It expands outward into a vast, dark, and utterly unknown infinity that we simply cannot see because its light hasn't reached us yet.
Which brings us to the ultimate mystery. If our observable universe is just one single patch in an infinite dark ocean, scientists theorize there could be countless other universes out there, making ours just a tiny drop in a grand cosmic sea. So, I leave you with this final thought to ponder. Does a multiverse exist? We might not have the proof yet, but the sheer, overwhelming vastness of space tells us for sure that our universe is definitely not the end of the story. Keep wondering, keep looking up, and stay curious.